When we look at number 1, what you need to notice or determine is if you can combine these. In other words, if they are like terms. So let's review for a second. If you had 2x minus x, what would you do to simplify? You would minus the x's? So when you say minus the x's, does that mean I go like this and I get 2? Okay, so back to the question. When you're combining those, what exactly are we combining? Does anybody know the answer? What's the answer? That is correct. How'd you get that? Okay. Can anybody talk about that, just not using the variable x, but only talking about the coefficients? Okay, so there's a 1 right here. Yeah, I agree. So say that again. 2 minus 1. This is the same base, therefore, we combine the coefficients. 2 minus 1, and then you leave the base the same. So 2 minus 1 is 1, so just 1x. Perfect. Did you change the x in any way? Did you change the x in any way at all? No. Does the x have an exponent on it? What exponent is on the 1 right now? A 1. Did we change that? No. So we did not change the base at all. All we did was took the 2 coefficients and subtracted them, right? When you approach these problems, the first thing you have to decide is if they are like terms. What if this would have been 2x minus y? What would you have gotten then? I'm sorry? The same thing, right? 2x minus y is 2x minus y. Is there anything to combine? How come there's nothing to combine? Because they're not like terms. Okay, so the first thing you have to decide when you're looking at these problems is if you have like terms. Okay, write this note down. These are like terms because, these are like terms because what you have to do is you first look at the index of each of the root. So this has an index of 2 and this has an index of 2. That's part of what has to be the case in order to say they're like terms. The index of both of them, or how many ever there are, of the root has to be the same. So this is a 2, this is a 2, we're good there. But not only that, but the radicand, that means the number underneath the radical sign, the radicand also has to be the same. So this is a 2 and this is a 2. I am not saying, because of this first weird example, I am not saying that this has to be a 2 and this has to be a 2. I'm not saying this and this have to be the same. What I'm saying is the index and any other indexes have to be the same, and any of the radicands have to be the same for us to be able to say they are like terms. So these indeed are like terms because they both have an index of 2 and they both have a radicand of 2. When you've decided that they are like terms, you simply, just like this, you only combine the coefficients. Okay, so I'm going to I'm out of space right there, so I'm going to rewrite it down here. Okay, so they both have an index of 2. So all I need to do, since we've already decided that these are like terms, I will take the coefficients and I will combine them. So in other words, I'm saying 2, the coefficient in front of this is a negative 1. So 2 minus 1 times the square root of 2 is 1 square root of 2, or just plain old square root of 2. I did not change the base in any way, just like I didn't change the x in any way. Okay, so either one of these would be acceptable. Okay, so on number 2, the first thing you want to do is to see if they're like terms. Decide if they have the same index. So that is this index of 2, and that's an index of 2. So index-wise, we're fine. Then this has a radicand of 3. This has a radicand of 3. Same index, same radicands. They are like terms. So then all I'm going to do is I'm going to take the coefficients and I'm going to combine them. So I am going to have 3 minus 3 times the square root of 3. Well, 3 minus 3 is 0 times the square root of 3. And what is 0 times anything? 0. Oh, okay, so when I look at this one, it is really obvious immediately that these two are going to be the like terms because they both have an index of 2 and they both have a radicand of 2. So I have a negative 1 right here and I have a negative 2 right here. And that's going to be multiplied by the square root of 2. And then I've got minus 3 times the square root of 6. When I simplify this part, negative 1 minus 2 is negative 3 times the square root of 2. Break the 6 down. You break the 6 down into 2 times 3. Are you going to get a group of 2? No. Okay. So this is not going to change at all. Am I going to combine these? No. Why not? They don't have the same radicand. They have the same index, but not the same radicand. So that's it. That one's done. All right, so when I look at this, I see that they all have an index of 2. Well, that's swell. But only these two have an index of 2, a radicand of 2. So only these two do I get to combine. So this one, that's a 3. I can't break that down. I'm not going to get any groups of 3. So that simply is going to come down. And then I have 3 square root of 2 and a negative 3 square root of 2. But 3 minus 3 is 0. And 0 times the square root of 2 is just 0. So 3 square root of 3 is the answer. Okay, number 5. Okay, so right now immediately it doesn't look like this is something I can combine. But I have to see if I can break anything down first. So I can break this into 9 times 6. Right? So negative 2, that's a 2. Not a very pretty 2. Negative 2 times the square root of 9 times 6. But the square root of 9 is what? A perfect square, right? So the square root of 9 is 3. So I'm going to have negative 2 times 3. And then I have 6. Can I break 6 down and get a group of anything? No. And then I'm writing the rest of the problem. And then negative 2 times 3 is negative 6. Times square root of 6 minus square root of 6. And here, when you get to this, I'm a little bit worried that people are going to go, oh, and now we take away those. Not that you would use that voice. But you don't take away these, do we? Because when we combine like terms, we have to leave the base what? The same. Okay? So be careful in your work. If you go a little bit too fast, I could see people doing that. Instead, since we know that this and this, these two terms are like terms, I need to combine the coefficients. So I would have negative 6 minus 1 times the square root of 6. Negative 6 minus 1 is negative 7 square root of 6, and then we're done. Okay, on this one, when I look at this, I immediately see that these are like terms and that this one is not. I also see that I can't break the 5 down any further, so I'm going to get negative 3 square root of 5. And then how many square roots of 6 do I have? How many total? Not physically written down, but how many total? I'm obviously not asking this the right way. How many square roots of 6 are there right here? I'm still not asking it the right way. This means square root of 6 plus the square root of 6. How many square roots of 6 are there? 2. How many square roots of 6 are right here? I get why it's confusing. It's all good. I get why why you don't understand what I mean. Okay, so this means that there are square root of 6 plus the square root of 6, and this means that it's the square root of 6 plus the square root of 6 plus the square root of 6. How many square root of 6's do I have in total? 5. So if I take the 2 and I add 3, I get 5. Okay, so when I look at this one, I see that I have 2 square root of 45 and another 2 square root of 45. So how many square roots of 45 do I have in total? 4. Okay, then how many of these square roots of 24 do I have? How many can I combine? There's just this one, right? And how many square roots of 2 are there to combine? How many terms with square root of 2? Just that one. Now, on the surface, it looks like we're done with that, except we have to decide if any of that can be simplified. So 45 can be broken into 9 times 5, right? So I have 4 times the square root of 9, and is it 9 a perfect square? So what comes out because of that? A 3. So 4 times 3, square root of 5. What about 24? 6 times 4, or 4 times 6, same thing. And we have a perfect square right there, right? 2. So on the outside here, I'm going to have negative 3 times 2, but on the inside, I'm still going to have the 6. And then this one, there's no simplifying, there's no other terms to combine with that. And that 2 is already simplified. So 4 times 3 is 12, square root of 5. Negative 3 times 2 is 6. Negative 6, actually, square root of 6. And negative 3, square root of 2. These are, even knowing they all have the same index, they all have different radicands, so that's done. Okay? All right, I've got negative 1 cubed root of 16, and I have a positive 2 cubed root of 16. Those are my like terms. How many do I get in total? 1. Cubed root of 16. So I have 1 times the cubed root of 16. And then I have negative 3 times the cubed root of 8. And I have positive 2 times the square root of 25. What's the square root of 25? Okay, so this part I'm going to simplify into 2 times 5, right? Because this is a perfect square. Perfect square. Okay, well, how can I break that 16 down? 4 times 4, but I'm looking for groups of 3, so let's do it one more time. Instead of perfect. This I can really break into 2 times 2 times 2 times 2. And I'm looking for groups of how many? 3. All right, so there's a group of 3. So I'm going to get 2 times the cubed root of 2. Okay, what about this? What can I break that 8 down into? Okay, 2 times 2 times 2. And I'm looking for groups of how many? 3. And there is a group of 3. So I have that negative 3 times the 2. And then I also have the 2 times 5. And then look, these are like terms. Negative 6 and positive 10, those are like terms. So I can combine those now.